So to start off explaining how the Earth can be shown to move with spectroscopy, let's start off with what is spectroscopy. Spectroscopy is the splitting of light to its emission spectra, which you've seen through prisms and rainbows and such. Why do they have specific bands of light? Well, that's due to the atom energy levels. This can be seen with jumps between the energy levels, and the most important one for this is the hydrogen Balba. Why are the set energy levels? Well, that's complex physics and well beyond the scope of this video. This is what an emission spectra looks like. What would you expect to see when it moves towards you? You would expect things to move. You would expect an increase in frequency when it's moving towards you, and a decrease when it moves away from you. You've heard this effect when an ambulance comes past you. When it's driving towards you, the frequency increases. When it's gone past you and you're going away, the frequency decreases, and you can hear that in the change in sound. So, next let's have a look at the Earth. This is the Earth and a star in the distance. One star and the Earth, that is not the Sun. Now we're going to place two observers on this. I'm going to place them here and here. And now we are looking down the axis of rotation, so we're looking down the axis. Next, they're both going to take spectroscopy readings off of the same star. Now this is the same star, and that's very important. Now, what they're going to expect to see if the Earth isn't moving is this, exactly the same spectra at both sites. This is what you'd expect if the Earth isn't moving. However, what they actually see is this, when the only way this can be explained is if the Earth is spinning this way, with the top one having an increase in the frequency of light and the bottom one having a decrease in frequency of light, having the shift. And this is what we actually see. We see that shift. Now, to explain how the Earth is shown to move around the Sun, you do the same thing. You measure 6 months apart, and what you have is the two measurements. Now, 6 months apart, because you need to be moving in both directions, you measure off the same star, doing the same thing again, and you get exactly the same shifts. One with an increased frequency, one with a decreased frequency. So, it's very simple to see that the Earth does in fact move, and you can show it using spectroscopy, and it's incredibly easy. That is about the 6th take I've done to not stutter while doing this. Jesus Christ.